Oh, there, I should probably unmute myself. How you folks doing today? Happy Wednesday. Alrighty, I'll get that pause. We got a couple things on tap today. Let me get this logged in over here. Alright, so we're moving on to the next chapter here, which it's actually, there's a lot of stuff happening in this chapter, which is really cool. This is a really good chapter. Adding a couple more tools to our toolkit to help us solve some problems. So let's take a look. Excuse me, here's our link. And then don't forget we got study group today, 12 to 1. So definitely encourage you folks to head out to study group. Will be well worth your time. Always worth getting the extra practice. All right, so we're starting on coding methods, handling exceptions, and validating data from chapter 5 here. We're going to do that today and Monday. We have project 2 assigned, and I think we've got that lab today we got to talk about as well. Hope your coffee's good. Yeah, so our lab here was, our validation loops was due this morning. So we'll talk about that lab. We've got the nested loops coming up due on Monday that we'll talk about. And then project 2, again, coming up before you know it. I know it seems like it's a long way off, but definitely you want to get started on that earlier rather than later. We'll take a look at this lab 5 here. So I'll start up a new project for lab 5. And this is for the Monday, Wednesday class here. There we go. Make sure we're in the right repository for you folks. So for lab 5, we were working on this grading program here, doing some sort of crazy sliding scale for grades. And practicing our validation loops. I'm going to grab all that. Come on, NetBeans. Killing me. I'm so close to switching. I don't really want to switch like midstream, but I'm really tempted here because NetBeans is just driving me nuts. Let's see. Then I got to finish testing and get our friends. Yeah, we definitely talk after class SP Java during lab time for sure. Close this one down. Not close, just erase some of that stuff. All right, and then we've got all of our instructions here. I'll just put in a little block, a little comment block. Right, let me log on. All right. So we're going to ask the user for their score, do this little validation loop thing, and then we'll ask them for the average score. Again, doing the validation loop, making sure we're getting values between 1 and 100. There. And then depending on how their score relates to the average, they get different letters here. So if theirs is better than the average, they get an A automatically. If the average is between 90 and 80, right, if the average is a B and they're within 10 points of that, they get a B. So if the average is an A and they got an A, they're still going to get their score. Right, this is kind of that last catch-all case here. So it's going to be a little bit funny. So that last catch-all should do it, Benny. So like if the average was 95 and they were 93, they're just going to get their score. Right? But if the average was less than 90 but more than 80 and they're within 10 points of it, they get the B. So even if the average is right at 80 and they're right at 70, which might be a C, we're going to say, okay, you get the B here because you're close enough to the average score. And then same with C. No, so I think this last otherwise here, like this should probably just be a last else, should take care of that sort of thing. So if we're dealing with input, we're going to need our scanner. Call it keyboard equals a new scanner. Given system.in. Right, and then we'll ask them here. Oh, we got to add our imports. Thank you, NetBeans. Little light bulb and add import. Remember to add this line up top. Import java.util.scanner. And then we'll say, please enter your score. Your score. 1 to 100. And now we've got two options here. Right? We can say, hey, int score equals the keyboard.nextLine. And remember, we can't just do a next line. We have to turn it into an integer. So we need integer.parseInt. Given the keyboard next line. No, I typed parseInt. ParseInt. It was not a helpful suggestion there. Okay, and then we can say our little validation loop. We can say, okay, while the score is less than 1 or the score is more than 100. Right, we said 1 to 100 is valid. So if it's less than 1, 0 or less, or more than 100, we're saying it's invalid. We should ask them again. Now, I don't really want to have to type this twice, though, right? So what I'm going to do, I'm going to just cut that out and put it inside of here. And then I'm going to start score as something that is invalid. So if score starts at 0, we'll ask them, hey, enter your score, because I know this loop will run once. So again, it could be a do loop as well, but I don't like do loops because of the semicolon. They drive me nuts. So I'll just do a while loop here, and I'll know I'm going to set score to something that will make sure it runs at least one time. So we'll enter their score, we'll get their value. If it's invalid, we'll just keep on prompting. And then we do the same thing with average. Give an int for average. And as long as the average is less, or average is here, we'll ask for enter the average score 1 to 100. And make sure we're setting average here. Right, so if you're doing the copy paste, you got to be careful. You make sure you get all those variables updated here. But now we should have those two validation loops for score and for average. Hector, thank you so much, my friend, for sharing those bits and donating to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. Whew, I'm getting better at putting that all into one sentence here. Thanks for coming along. Yeah, it should just be one score and one average. So what our score is and then what the average score is. Okay? Then we're going to see what our grade was, right, based on this sort of logic here. So no matter what it is, if we did better than the average, it's automatically an A. Luskin, you got it, my friend. You need a knock-knock joke. Where is my backpack? There it is. Had enough nonsense already this morning? Need knock-knock jokes? All right, let's see. Here we go. Knock, knock. Who's there? Some. Some who? Someday you'll recognize me, hopefully. All right, that one was... okay, I don't know. Maybe that was okay. Knock, knock. Who's there? Isabel. Isabel who? Isabel working? That one's kind of decent, right? All right. Keep those handy, just in case we need another break. All right. So, if our score is greater than the average, automatically it's an A. Right. So actually, let me move all this down here because it's taking up a bit of space. Let's go down here. So we'll do that first one here. So if the score is greater than the average, we print out, you got an A. Right, that's it. They got the A. If it's not greater than the average, then else if the average is less than 90 and the average is greater than or equal to 80, right, we're ANDing these together. Both need to be true. And the average minus the score is less than or equal to 10. Right? Does that make sense if we're within 10 points? So if the average minus our score is less than or equal to 10, then we're within 10 points of the average. And this is true, and this is true. So all three of these things must be true for us to get a B. I'm going to just copy that, I guess. You got a B. Right? And then same, we're just going to pretty much repeat this line here, but now our numbers are different. So now we're less than 80, or more than 70. Still within 10 points. Okay? Then we have, now this is if the average is less than 70 and our score is more than 50. Score is more than 50. We get a C. Right? Otherwise, I don't know, you keep your score or something, or you got, but don't necessarily, you just get your score. You got your score plus score, I guess. Not, that's a little bit ugly, but that's okay. So it's A, B, or C, depending on some of these, right? Oh, I'm sorry. This was supposed to be C as well. So this, or this, actually, here, depending on where that average went. So we could actually put this one in as an or if we wanted to go crazy here. Right, we could say all of that, right, or this one here. And it doesn't hurt to force some order of operations, but remember, ors actually have a lower precedence than all the ands. So like all of this together or all of that together. You get the C, and then we can just skip out on these ones here. Does that make sense? Or here, maybe I'll leave that, should I leave that commented out, or maybe I'll leave that commented out. Does that make sense if I just leave that there? Right, that was possibly another option, but we could just put it up here instead. It doesn't hurt anything, right? If they're both getting C's, then, right? Sure. And then otherwise they get their score. Well, this was what, combined with above? Combined with above C instead? Sure. Okay, let's try it. So let's give it a run. Yeah, I'm hoping it'll run. Let's see. Maybe I'll need to do that compile on save thing. So good morning. I went out to the cafe around the corner and I got myself their mocha. So I've got that in here, which is a little sweet though. It's usually it's a little sweeter than what I usually drink. Okay, come on. So if I just do a build here, oh goodness. I do need to do it though. Clean and build. I do need to do that. It's telling me I don't, but it's wrong because NetBeans is crazy. Yeah, so if the average is above 90 and the score is below the average, then we're just going to hit that last else. Because all these other ones we're looking at, average had to be particular. I guess this one here is if the average was less than 70, yeah, so the average was above 90, we'd never hit that last one. So we'll just get an else, you just get your percentage score. Let's try one more time. There we go. So what is our score? So if we say like 110, it doesn't let you. But we can say 100, sure. Average score, 100. You got your score, 100. Because we were at the average, sure. Right, let's try it again. How about if we were, say, 95 and the average was 90? We got an A, because we did better than the average. If we got, say, an 82 and the average was an 87, we got a B. Right, we're within 10 points of that. So we could try all the different cases here and make sure we're getting all the different letters. So the average was a C and we're within a C, we can try that. So if our score was, say, 67 and the average was 72, we should still get a C, right? Or if the average was less than 70, say like 60, so if ours was, say, 55 and the average was 69, we still get the C. So the average was less than the C, but we're above 50. So just trying out all those different cases to see, can we make sure that each one of these is doing what we expect it to do. That was the idea with this one. Does that make sense? So just practicing, a little bit more of this logical stuff, doing a bunch of anding and ors if we need to, and then our little validation loops here. Now, these ones are tricky because we're saying if it's less than 1 or greater than 100, right? So this was the invalid range to make this true, where this one was the within a range here was true, not invalid. This is the valid range. So you just kind of have to think about and puzzle through what are we trying to have happen here? And like with this one, if it's invalid, we want it to run again. With this one, if it is valid, right? If it's one of these rules, then we need this code to run here. Excuse me. Oops. Try and line it up a little bit nicer here. Okay, let me go commit this to GitHub here. This is the Monday, Wednesday one. There we go. For Lab 5. All right, awesome. So we got that one. Yes, we can discard. So I should have named these better. I want to see, what was Lab 4 again? Yeah, number guessing game. Okay, cool. Cool. So we're going to come back to that here in a minute, because we got some fun stuff we can do with that. So let's start a new project here for Chapter 5. This is our Chapter 5 methods. So methods are just another tool we're adding to our toolkit, a way for us to solve problems. Now, what's weird about methods, though, is you don't technically need them. Right? With these other tools, like when we looked at doing these if-else branches, we looked at using our loops. They were the only way to solve particular kinds of problems, to run code over and over and over as many times as we wanted. We didn't have other options. When it comes to methods, technically we don't need them, but it makes life a lot nicer for us. And they do a couple things. So let's actually go and look at our lab here again. So let me go open that one up. I'm just going to go copy paste it here from GitHub, because I don't want to have to open it up in NetBeans. 2022, Monday, Wednesday. Lab 4. So this was our number guessing game, right? We'll copy this in. Okay, and then yeah, we want to import our scanner. Cool. So this works, right? We had no problems with this, but excuse me, it's I don't know. We're doing a couple things more than once. Right? They're asking if they want to play. It's okay. But what we can do with methods is a couple things. So one big advantage to methods is we get to put a name to a block of code, to a chunk of code, right? And then it's repeatable code. So when we say like keyboard.nextLine, this is actually calling a method for next line. It's doing something, some operation here, and it's giving us a value. When we say print line, this is actually a method here that's doing something. It's printing this text to the screen here. So we've been calling methods all along. Like integer.parseInt. ParseInt is the method here that gives me back an integer value. Math.random is a method that gives us a value. So we've been using them, but now we're going to look at how we can make our own. So far, everything we've been doing is inside of this set of curly braces of main. Public static void main, this curly brace down to this curly brace. So what happens with methods now is they are defined outside of main. So main is actually a method itself. So this here just is a method. This happens to be the starting point. So for any Java application, when you go run a Java program, it looks for this method called main and runs main. The other methods we're going to start defining and calling and writing ourselves here. So what we can do is we can take some chunk of code and we can put a name to it. So like this, hey, do you want to play a game and play? Let's do that. So I'm going to grab all of that. I'm just going to copy it here for a second. And we're going to come down outside of the curly braces now. Outside of main. We're still inside the curly braces for public class Chapter 5 methods. So it still all belongs in that same class here. But now it's outside of main. And we're going to write a method. So for now, they're all public static. So public static for all of our methods. We'll talk more about that next chapter, what that all means. And then we can say this is void. So void means it doesn't return any values. So we'll do void ones first, and then we'll do some returning value ones after. So void method here, and we'll say ask the user if they want to play. And then a set of parentheses. And then a set of curly braces. So everything inside this set of curly braces then belongs to the method we're writing, ask the user if they want to play. And here I'm going to copy this in. So we'll make the scanner object, ask if they want to play the game. We'll get this value for play. Now we need to do something with it. So we don't actually want this to be a void method. A void method just does a task and then stops. Like there's no chance to return something. So like when we say keyboard.nextLine, we're getting a value back because we can assign it somewhere. With like string play is keyboard next line. So this is going to return a value here. If we want, let's just do like a boring, let's do this one here. Let's do public static void print have a nice day. Oops, and then a set of curly braces. So there we can say have a great snow day. Sure. And now instead of calling this code here, I can use the name of the method. I can say print have a nice day. When we get to here, it'll say, oh, let me go find that method and run everything inside of the set of curly braces. And here, I don't know, enjoy the sunshine. And maybe we say, are you going to go sledding? have an ice day. So anything inside this block of code here essentially is getting put right here when we call this method. So it's saying, hey, go run everything inside of here and then come back when you're done. So that's a void method. It doesn't return anything. So void methods don't return values. They just run. Okay, like out print line, it doesn't return anything. It just runs and does something. Similar to our own method here. Okay, but then ask users if they want to play, we want to actually return a value. So I'm going to say public static string. So if it isn't void, you need to tell Java the return type. What type of value is going to be returned? So in our case, what kind of value are we going to get? Well, I'm going to get a string value here. Right? So like when we say keyboard.nextLine, we can save it as a string. I can't save it as an integer because it says, hey, invalid types. String cannot be converted to int because keyboard nextLine returns a string. We have to save it as a string. So same idea with that. So I can say now ask the user if they want to play. I can take that whole method name and I'll put that here instead of this. I can just say, okay, ask users if they want to play. When we call this method, it's going to jump down here and run these 3 lines. Oh, and then now, so now it lit up red. We changed it from void to string, and it's saying that little red error here, missing a return statement. So the keyword here, our reserved word here is return. We say return play. So we get a value, and we have to return something that is a string here to make the method happy. So it's just putting a name to what we're doing here. So ask users if they want to play. Great. Now it turns out we pretty much do this down here again too. So we can use this same method now, ask users if they want to play, right here instead. So now we're doing the exact same code more than once, and we don't have to type it more than one time, which is pretty cool. So the other advantage to methods, not only does it put a name to what we're doing, like, hey, print have a nice day, it lets us repeat that code without having to have it in here more than once. So there's a pretty good general rule of thumb when you're writing code here. So like anytime you're writing code, if you write the same code twice, you should feel bad about yourself. And you know, I say that, you know, half-heartedly joking, not actually feel bad about yourself, but you know, that idea that, well, we could do better, right? And the better is let's turn it into a method. Anytime you have to do something more than once, it's an indication to you that it could be a method here, so you don't have to do it more than once, right? All you have to do is then ask for it by name and say, hey, ask the user if they want to play. Now, I know it said again, and this one doesn't say again. I'm not going to feel too bad about that. We'll say this is close enough. So it wasn't exactly the same, but we'll say it's close enough. Okay, so we can repeat code here now without having to have it in here more than once, so we can feel good about ourselves. All right, now this next step here, how high of a number do you want to guess? Let's take this, and let's make another method out of it. So let's say public static. Now this is an int value. Ask how high to guess. And again, it follows the same naming convention, right? Starts lowercase, and then every next word gets an uppercase. Yeah, exactly like a Python function. Yep. Python calls them functions. We call them methods. That's what it is. And we'll return the highest number. Now, you'll notice, though, it's upset about this keyboard thing. It says can't find symbol. Remember, we talked a little bit about this idea. It's called scope. So if I have a block of code like this if block of code, if I declare a value in here, int some value equals 10, I can't use some value out here. I can't print out some value, right? Because some value doesn't exist outside of this set of curly braces. Whenever you declare something, it's only accessible inside that set of curly braces or deeper. Like, you know, you could go further in. So if we declare it out here, we could use it inside here. So the scope of this value, right, it's only inside of this set of curly braces. So the curly braces also help determine that scope where a value is accessible and usable. So I can't use it there. So because this is defined inside of a method here, it can't access it. So that's why I had copied this before into the previous question. So we'll just grab that, create a new scanner here, get the value, return their highest number. So you say, okay, great. We'll ask them how high to guess. So all of this is going to be then replaced with ask how high to guess. And again, we can get rid of the prompt. And then our semicolon. Okay, and then we can generate the random number. Now, here again, we can take this, okay, let's guess a number here. And let's take that out. Let me cut that out, and let's make another method. Public static int ask for a guess. Now, okay, we'll put the scanner in, but we have another problem now. The next problem is, what's highest number? You know, we can return the guess here. I don't have access to highest number. Now, this one's solvable. Hey, thanks for following along. So, in this case, another thing we can do, so methods now can also accept values. And we've been doing this before. When we say integer.parseInt, where did it go here? You have to give it something inside the parentheses. Keyboard next line, we don't put anything inside the parentheses. We call the method, it does something, we get a value back. ParseInt, you have to give it a value. So to tell Java you want a value here, we say, hey, I want what type? So this is a type of integer, and what do I want to call it? I want to call it highest number. So if you tell me the highest number when you call this method, then I can use that highest number inside my method. So when I go to ask for a guess here then, we'll say their int guess is equal to ask for a guess. I can't just do a set of parentheses. It says method ask for guess in class chapter 5 methods cannot be applied to given types. Required int found no arguments. We didn't put any arguments inside the parentheses here. So argument is the technical term for what you put inside the parentheses. So like play.equal ignoring case y. Y here is the argument given to the method equal ignore case. Right? This string too high is an argument given to the method print line. So we can give it the max value. What was it? Our highest number. So we give it the value inside the set of parentheses. So this is called the argument here. So that way you can use it inside the method. So if you want to get technical here, values defined are parameters. So this is a parameter defined to be. So you say you pass it, you give it the value. We're saying, hey, call ask for guess and give it the highest number. You pass that value. This is called a parameter. When you actually give it the parameter, it's known as an argument. So it's an argument here, and it's a parameter here. I don't really care, and most people understand the difference, or don't really care about the difference. So we use the words interchangeably. But if someone wants to get particular, this is the parameter. Up here, it's the argument. Okay? So sure, we'll ask them for a guess. We have our number of guesses. And then let's do all of this too. Let's take this one out here. And we'll say, how about public static? This one's just void. We don't need any return any values here. We'll say print too high or too low. But to do that, I need the guess and the random number. So I can define two different arguments. So guess, comma, int random number. So you can have more than one argument here. Have more than one parameter or argument. Just comma separate. Separate them. Right? So as many as you want. There is a limit, but it's like ridiculously high. We can probably Google that. Java max parameter. Number of parameters. Oh, it says there is no limit, really? That can't be right. There's got to be some limit. Okay, it is 255. Oh, so 255 parameters is the max here. If you've got too many, something's going wrong. And there's other sorts of design ideas and things we'll talk about to make sure we're not passing too many. But, 1, 2, 3, 4, you should be fine.
Can you quickly do that?
Yeah, sure. Getting your schoolwork done? Okay.
What are you talking
about? Parameters, passing to arguments. All right, so we can pass it those two values. So then when we go to print too high or too low, here, we'll give it our guess, comma, the random number. And now our guess a number here, again, we've already done that, so we can just ask them for a guess. Right, so again, we're saving a little bit here. Just back it up a little bit here. Okay, so we'll print too high or too low. We'll ask for another guess. We'll increase the number of guesses here. Say, good job, you guessed it in some number of guesses. Ask if they want to play again. So now you'll notice the entire game basically fits in one screen worth here. My font's a little bit large, but you can kind of follow along. So just by reading the main method, you don't really actually need to go and look at what these other methods are doing, because we just see what they're called. Right? So putting a nice name to that block of code means, okay, I can just kind of skim through main, and I get a pretty good feel for what's happening. So it helps add to the readability of your code. And then if I really care and I want to find out what it's doing, I can go scroll down and see what's happening behind the scenes. Right? So, okay, ask if they want to play, as long as it's yes. Okay, we'll ask how high to guess. We'll get a random number. We'll ask for a guess. All right, we're starting to count our guesses here. As long as it's not the random number, we'll print too high or too low, ask for another guess, count their guesses. When that's done, tell them they got it in some number of guesses, ask if they want to play, repeat. Repeat, 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 repeat. Over and over and over and over. And then print have a nice day. Have an ice day. It is kind of icy out, I guess. So you could have an ice day. And now, another cool thing, as we start having all these methods here, like it's a little bit to scroll up and down. It's not too bad here to scroll up and down. But over on the left, you probably have this Navigator window. And if you don't have it, you just go to Window and Navigator. You can see the method by name, and you can just double click them, and it's going to jump you right to that method. So if you want to go see one particularly, you can just go jump to it. Now this isn't too bad, was it? 73 lines of code. So it was originally 42 lines of code. Right? So we've actually added more lines of code because we have to repeat the scanner thing a couple times. Well, these headers take up more room. We have more curly braces. So it's a little bit longer, but I would say it's probably a little simpler now. And we didn't need methods to do any of this, right? It was already solved without methods. But by using methods, we're able to put names to what's happening, which I think is probably the most important thing here. We can break this up into little chunks here and solve little problems at a time. And then we can avoid repeated code, like ask them how high to guess, or no, ask for a guess. We don't need to have this same code in here twice. Right? So we can be more efficient here and not feel bad about ourselves. So this idea of taking a big problem and breaking it down into smaller methods has a really cool technical term. It's called functional decomposition. It's one of my favorite technical terms. And I love throwing this out when the family gets together for parties and things, but unfortunately my family knows I'm a giant nerd, and my brother's a software developer, my father-in-law is a software developer, so it's not weird to any of them to throw these terms around. But if you go out to some family outing and you just talk about, oh man, I was doing all this functional decomposition in class, people are going to look at you funny. But then you can explain that this is just a technical term here. We're just taking a big problem and we're breaking it down. We're decomposing it into smaller and smaller and smaller and smaller functions. The idea is that solving a big problem is hard, right? Especially for a computer, right? To get every single step of this step and this step and this step and this step and this step, breaking it down for a computer is hard because computers are dumb, right? We have to do small steps and small steps and small steps. So by taking a big problem and breaking it apart and doing functional decomposition, we can say, okay, well, really, I have to do this, and then I have to do this, and then I have to do this, and then I have to do this. And each of those little thises is a nice small problem to solve. Okay, how do we ask if they want to play? How do we ask for a guess? How do we ask how high? How do we print too high or too low? Right? As many of these steps as we want to take, we can break up into smaller and smaller and smaller functions. Does that make sense? So that's our fun technical term for it, that functional decomposition. We're breaking down a big problem into smaller and smaller and smaller and smaller problems. So let's actually do this. Let's go look at project 2 here. Now, methods are not required. You don't need methods for any of this stuff, but we could use methods if we wanted to solve this problem. Right? So I'm going to start up a new project here. And what I'm going to do is I'm going to write some methods that don't actually do anything yet. So we're going to take a big problem, we're going to break it down into smaller problems, but we're not going to solve the small problems yet, right? So we'll call this project 2. So we need to do a bunch of things here, right? So there's a bunch of stuff happening, right? We'll figure this out as we go. So the first thing we have to do, right, is we're going to get an int for total income. And how about a method? So we'll say get total income, or ask user to enter incomes. Sure. Now I don't have a method for that, so let's go write one here. Public static, and that's int, ask user to enter incomes. Now it's not going to compile right now because it's missing a return statement. So for now I'm just going to say return 0. So I'm putting something in here just to make the red go away, and just leaving myself a note, we actually have to do this. And then I'll have an int for total deductions, is ask user to enter total deductions. Okay, again, same idea. Let's just make another method here. Public static int ask user for total deductions. We can do those little validation, or those little loops with sentinel values inside of here, right? Enter some values. I'm going to sum up the values here. When you give me some kind of weird value that wouldn't be normal, I know to stop the loop, like 0. You probably don't have a W-2 that's 0. You probably aren't claiming a $0 deduction. So you can just keep entering values until you enter 0. Sure. Okay, and then we need deductions then to be whatever's bigger. So then total deductions can equal, pick larger of deductions or standard deduction. And to do that, then we'll need to tell it what our total deductions is. Right, so then we can have a method that does this. So public static int, pick the larger, given an int for total deductions. Deductions. And again, now, that's we have to do. I'm just going to return 0, but you can see which one is larger, the deduction you gave me or the standard deduction, and I can give you back the bigger one. Right, now that gets a little bit long, but again, your font size is probably not quite as large as mine, so I've got this zoomed in a little bit here to make it show up better on the screen. Okay, cool. So we're cruising, right? We did W-2s, we got deductions, we figured out which one was bigger here. Now we can calculate the adjusted gross income. So that one's like not even, we don't even need a function for that, right? That's just income minus deductions. That's pretty straightforward, right? So our adjusted gross income is total income minus total deductions, which now is either the larger of our actual deductions we claimed or the standard deductions, right? We can do that. Sure. Right, and then calculate taxes owed at each bracket. Okay, so remember, 3 things happen here. Either you pay none of the tax, you pay some of the tax, or you pay all of the tax. Right, so we've got options here. If we want, we could just break it up and, say, do different methods for each one. I'm not sure what's going to be easiest here. We got a couple options. So one other thing that might work for you here, and again, it's an option, not necessarily required here, but this might work for you. And if you already took a different road, go for it here. But we could say, hey, I want an int for taxes owed at 10% is going to be, okay, well, what do we do? Yeah, SP Java. So the next project we'll be using functions and other things from next chapter as well. We'll have to be using those sorts of things. So we gotta learn about them first before we learn about classes. So taxes owed at 10%. So the logic here for this, right, is essentially the same thing no matter which bracket you're at. We're just looking at different values, right? So we said, hey, if you are less than the start here, it's nothing. If you're more than the max, it's all of it. Or if you're somewhere in the middle, it's some of it, right? For any of these brackets. So if you made less than 0, there's no tax at 10%. If you made more than 9,950, it's all of the 10%. If you're somewhere in the middle, it's some of the 10%. Right? And it works for all the brackets. The only one we don't really have is this top one here. There is no max. Fine. The max integer is 2 billion. I don't think anyone actually claims 2 billion worth of this is earned income or wages. So this is specific to wages. It's the income tax. Capital gains, which is money that you've gained from selling capital goods, is different from wages. So no one has a $2 billion wage income here. They get lots of money. They can get billions in capital gains, but we're not talking about capital gains here. So the max int is probably fine. So something we could look at then, we could say, calculate taxes for bracket. And then we could give it a couple things here. So this one might be a little bit tricky here, but I think it'll work out. So an int for calculate taxes for the bracket. So we need a double for the tax rate, right? So that's like 10%, 12%, 22%, whatever here. We need an int for the start of bracket. We need an int for the end of bracket. And then we need an int for income to tax. Right, so if we give it a bunch of different things here, and I'm actually just going to enter that down because I want to make that a little easier to see here. And if you tell me the percentage, you tell me the start of the bracket, the end of the bracket, and how much income that you have to be taxed, I should be able to calculate that, right? Again, this is to do, right? It's either none, all, or some, right? Right, it's none if you're less than the start, it's all if you're more than the end, or some if you're in the middle. Right, so for now I'm just going to return 0. Again, but we can use this sort of information. So at 10%, it's 0.1, right? The start was 0, the top was 9,950, and the income to be taxed is our adjusted gross income. Right, and we can follow this same sort of logic then. So if the logic is the same, and the only thing that's different are the values here, right? It's the same arithmetic no matter what. We can also use the method here. Right, and we can do this for all the different brackets. Again, you have to just go and fill out the numbers, that sort of thing. Does that make sense? So this is a little bit trickier using our method here, but the logic is exactly the same no matter what the numbers are. Right, whatever the percentage is, I'll take that percentage. Whatever the start is, great, I'll look at the start. Whatever the end is, I'll look at that end. And then how much income are we taxing? Now you'll notice this variable name doesn't match this variable name, and that's okay. Yeah, we could do all of them, right? It's the same arithmetic no matter what the start and end and percentages are. Right? It's either none of it if you're less than the start, it's all of it if you're more than the end, or it's some of it if you're in the middle. We just need to do that arithmetic. Excuse me. That's one approach, right? It's definitely not necessary. You don't need methods to solve this one. Right, and you might already be working on an approach that's great. If you like this idea, go for it. Right, it works out pretty well. Then we'll just keep on going, right? Da 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 for all the other brackets. On and on and on, on and on and on, and then we can calculate those percentages owed. Right, you can have those percentages, more things to do. Right, finish this. Yeah, the only thing that changes are the tax rate, the start of the bracket, the end of the bracket. And your income to be taxed, I mean, it actually stays the same for all of these ones, but it could be different anytime this runs. So when I run it, it's going to be different than when you run it. It will be different than when someone else runs it, right? That's what's great about our programs that ask the user for values. It can be specific to their values, right? So that's one option we can do with a method here if all of the arithmetic is the same. The only thing that's different are these tax rates, right? We okay so far? So we looked at some basic methods here. This one is getting a little bit more interesting. But again, it's the same code. The only thing that's different are some values. So if it's the same code with just slight differences, there could also be a method here because we can just give it those different values here, which is really cool. Right. All right. So let's see. We also had just finished lab 5, right? Lab 5 of those are our validation loops for our grades here. So with this one here, these two were very similar, right? When we looked at our lab 5. These two functions here were basically the same thing. What was different about them? If we look at these two, what's different? So if we wanted to try and turn this into a method, what do we notice about these two blocks here that are different, right? Because it's essentially the same thing, right? We've got our averages here, we're validating, but the difference, yeah, well, the variable, sure. So we could assign, so if we were to turn it into a method here, we could just assign it to a different variable. Yeah, definitely. It could be a different variable. But what else is different? Yeah, the prompts. Thank you, Mike. Yeah, this print line here. So if this is the only thing that's different, essentially, that could be an argument to a method. So we could write a method here then. So they could actually go above main. I like the idea that main goes first. Java really doesn't care. So I'm always going to put things after main myself, but that's okay. So if you're going to return a value here, we'll say this is public static int, ask user for value 1 to 100, given a string for the prompt. So if you tell me what the prompt is, I can use that prompt here. So I'm just going to copy this essentially. And we'll say this is, how about a score, I don't know, value. As long as the value is less than 1 or the value is more than 100, then instead of print line this here, I'll just print line the prompt. You tell me what you want to print, I'll print it out. And then we'll get our value here. Oh, we need scanner again. So let me go copy that line. Sorry. Here's our scanner. Okay. When we're done here, I can return value. So now, instead of saying score is 0 and doing all this logic here, I can say ask for an input given this prompt. And I don't need to do this. And then same for average now, right? Average can be ask the user to enter value 1 to 100 given this prompt. I don't need to do any of this. Right, look at that. Isn't that like a little cleaner here? So now we're doing the same thing. The only thing that's different is this prompt here. Right, you want to see another crazy thing? Let's make this even more interesting. So let's just say enter a value and validate range. Let's say, how about an int for min and an int for max? Now I can say, okay, as long as you are less than the min or more than the max, I'm going to keep you in the loop here. Right, so I could change these ranges if I want. Right, so enter your score, 1 and 100 for min and max, 1 and 100 for min and max. So now my method here can be used for any sort of input validation. That's an integer, right? You give me the prompt, and I'll tell you what is the minimum and what is the maximum. And the method works. Now, the downside here, this int 0, this might actually be bad, right? Because the possible range could be less than 0, and then this loop would never run here. So this is a little bit risky here, right? So maybe it makes more sense to do this as a do loop now. So we'll say int value. I hate it, but it's okay. We'll say do while here. So we do need to change that here. Does that make sense, right? Because I don't know if 0 was actually an invalid value before. So doing the do loop where it will for sure run once here and then check to see if it's valid or not. So I can't give it something that's invalid if I don't know what the valid range is. Now we knew we were saying 1 to 100, but right, this is the safer approach here, right? Does that make sense? So let's look at, here we got a couple things. So let me, so you can uncheck this box and commit just a couple files at a time. So I'm going to do it in separate commits just because it shows up differently in the history. For your purposes, it shouldn't matter because it's all one repo, but I want this to show a little nicer. So this is lab 5 with methods. I'll commit that. And then I want to do all of the chapter 5 stuff, examples first. So here's chapter 5, examples. So we've only gotten through about half the chapter. There's more to it. We haven't gotten through it yet, but that's okay. We'll get to it. And then here's project 2 methods. Right, let's see. There we go. Project 2 methods. Okay, so now they're all separate commits. The reason why I like that, when you go view this on the website here, view on GitHub, there's a particular view you look at that shows you the commits. And so you'll notice there's like, these are the commit messages here. These are the folders. So I can see this was lab 5 with methods was the commit message. This, I can see project 2 was the project 2 method. This was the commit summary. So the commit summary show up here, or you can also go to this commits button, link here, and you can see the individual commit messages that you give it. Again, for you're doing one repository per project, per lab. It doesn't really matter much, but I'm trying to keep things a little bit more nicely organized here, so you can kind of go back and see some of the history on this stuff, if that makes any sense. Okay, so sure, now we could change it up, and then again, we could do some sort of thing here with turn these into methods if we wanted, or have one method. I mean, we've got lots of options here. Maybe we might have, you know, a method for checking for an A, a method checking for a B, a method checking for a C. I don't know. We got lots of choices. We okay so far? I think we should try it now. What do you think? Should we try some of our own methods? So let's talk about the next lab here. So let's let me pull up another link for labs here. We'll add another lab. Excuse me. Let's be our lab 7. These lab 7 methods will be due next week, 10 a.m. And we're doing 10 points for each lab here. Let me go add a grade item in the labs category. Right, you're going to turn in the labs category a text submission, no file uploads, thank you. And here we go. Let's go make lab 7. Yes. 1500, winter 2022, lab 7. Oakland Community College Java template. There we go. Feedback pull requests. All right, here's our link. Cool. And please submit the feedback pull request URL. All right. So what we're going to do, we're actually going to take the... Oh, what's going on here? One of my kids is trying to call here. It's silly. We're going to do the stuff from Lab 6. We're going to expand on Lab 6. So if you're not done with Lab 6 yet, that's okay. So working with Lab 6, we're going to include methods for prompts, right? Things like entering values. So in Lab 6, let me open up detail again here. We'll take a look at that one real quick. Right, this idea we want to display those shapes, right, with our nested loops. Let's find that one here. Sorry, is that really loud when I'm like drumming on my mouse pad? Right, this idea with our loops here, right? We said for the different shapes, right? For square, we said let's ask for the size or the height or something. For rectangle, we need length and width. For triangle, we need height of a triangle, right? Those prompts could be turned into methods, right? The validation loops, right? And we could turn that into a method, I guess. That one may be a little bit trickier, but we could do it, right? So we're going to start looking at how we can turn all of this into methods here. Values, validation loops, you know, so these sorts of things here as methods. Okay. Then we're also one other thing, we're going to, and then add, also add a new shape. Or each printing, right? Each printing shape should be a method like, hey, print square given some value, print rectangle given some values, print triangle given some values. We could do those, right? Then we're going to include a new shape, the equilateral triangle. Equilateral triangle. So the first triangle, right, was this right angle triangle here. For an equilateral triangle, it's going to look a little bit different. So you want to think about what's the relationship between the number of stars and the number of spaces. So if I say this is size 7, I want odd numbers of stars, 1, 3, 5, and 7. Now you notice here, at 7 there's no spaces. With 5 there's 1 space. With 3 there's 2 spaces. With 1 star there's 3 spaces. So there's a relationship between the number of spaces, right, decreasing, and the number of stars increasing. So we're going to think about that for our shape here. And I think if I do this formatting here, there we go. It should look a little nicer here. In the validation loop, ensure only odd numbers are entered. Right? You can't have an even number because then it just doesn't work out quite right. So only odd numbers are allowed for a validation loop. So we need to find some kind of arithmetic that'll check for even versus odd. But I can't say, hey, if the number is 1, or I can't say if the number is 2, or the number is 4, or the number is 6, or the number is 8, or the number is 10. We'll just go on forever, right? Because I could say, hey, I want like 10,000 size, which would be nuts, but that's a valid integer. So we got some options. Okay, so we're going to look at how we can methodize that. That's probably not the term. How about functional decomposition from Lab 5? Break it down into small problems, right? How do I get a prompt? How do I enter values? How do I do these validation loops, right? What sort of things am I checking for? And we'll also add the new shape here. And each printing should be a method, given the size as an argument, or as a parameter, right? Size or argument parameter. Parameter. I think that's right. All right. Awesome. So I think we'll call today good. We'll come back on Monday and we'll finish out the chapter. So we've got the lab to work on today. SP Java, you wanted to meet. I can hop on my Zoom call, the same link. And if anyone else wants to chat, happy to talk with you. We'll try and get this lab knocked out. If you haven't got the previous lab done yet, right? Maybe do them in order, or if you do this one first, you have essentially done Lab 5 as well. So maybe that's an option for you. Like if you want to turn this one in for Lab 5, that's perfect, or Lab 6, that's perfectly fine. But Lab 6 is still due before this one, right? So Lab 6 is due Monday, this one's due next Wednesday. That sort of idea. So you do have a little bit of time if you need it there. We should be able to go from there. All right,
Yeah.
let me save that one. Oh yeah, now I'm gonna need some more coffee. Okay, so let me know what I can do. We'll hop on, send me a message on Discord, shoot me an email, and we'll go from there, okay? I think we've got our quiz here, right? That one's coming up due, is that tonight? Yeah, the Chapter 4 quiz. Oh, no, the 14th. Okay, so we finished it on Monday. That's right. So the Chapter 4 quiz isn't due till Monday. Don't forget about that one, and then we'll open up the Chapter 5 quiz on Monday as well. I got to change all those dates when I copy-pasted. Okay, any other thoughts, questions, concerns? We feeling all right? We know what we're working on? We can just get practicing? Again, I've got some examples. The book takes you through some other examples. They keep modifying their project they've been working on. It should be a lot of fun. Okay. All right, take care, and I'll see you folks around then.